last time we were talking about... Oh, am I really laggy, by the way? Looks like I am. Okay, maybe it's a little better now. Okay, last time we were starting to talk about... Is it better now, or is it still really chunky? Someone's got to say something. A little better. It's okay. You know what? I'm going to close a bunch of things. I have a billion Chrome tabs open right now, and we all know how much Chrome likes to just eat all of your RAM. So close that. Now you get to see me managing my computer resources to see if I can improve it. So Dante, hopefully after today's lecture, you'll have much of the information you need. There's a lot of gaps currently because I know that you came from the engineering side, so you don't have the background with objects, where 162 students did have that background. So there's a lot of gaps that'll hopefully be filled in today. It looks like I'm coming in smoother. Am I? Let me know. I'll do a little dance until you can confirm if I'm chunking or... Yes, you're smooth. Thank you. Okay. The function headers go in like the regular... Like you'd put them like above the function themselves. You can put them in both. You can do really whatever you want as long as you're consistent. Okay, here we go. I will now switch to the actual lecture content. So this is where we ended last time, right? We were talking about this two situation. And in this particular case, by saying student, a student, we created a student object in static memory. Like the computer knew, oh, okay, so when they hit run, like they knew at compile time, like, oh, okay, I'm making a student. It's going to be a default student with the default values that we assign in the constructor. We'll talk about that more in a moment. But then down here, I'm saying, no, make a student pointer called, what am I guess, that's going to be equal to a new student that goes and gets created somewhere in dynamic memory. So this is what we have. What am I is actually a pointer to a student, not a student, where a student is a student. It's a variable that contains a student, where this is a variable that contains a pointer to a student object. This is going to act in a way kind of like your primitive types, what you're used to. This is going to act like your things like your lists in Python. Your, I don't know, what else do we use? Stacks, not stacks, sets as well. So this is actually what we're used to in Python once we start working with more sophisticated things. So what am I missing here to end my, oh yeah, here's a good quiz. What very important thing am I actually missing here at the end of my code? Anybody know? Someone's gotta know. I'll wait for a boop before I go over. What am I missing? Delete, absolutely correct, A+. Technically, I guess, you know, when this program finishes running, the memory will be freed up anyways, but good practice, I should have a delete here. Oops, not what I wanted. Okay, more functionality. One of the first things we'll add to our classes as we create them are getters and setters. And these are very, very simple little methods that are used to access and set information within the an instance of an object. This would be like setting the attributes to a certain value or getting access to a certain attribute. Because technically, but you know, good design would say we're not actually really supposed to access attributes directly. And this is actually one of the reasons why we use that private keyword before. And instead, we write these functions to effectively be the middleman between these attributes. This is how we access them, is through these getters and setters. Now, you're probably thinking, this seems really stupid. Why do we have this middleman? Why don't we just access them directly? And you've got an, like, you're raising a good point, but there's an answer to that. But first, I'm going to show you a little bit more explicitly what I mean when something is set to private versus public. If we go look at our student C++ file, we've got these attributes set, and we'll look at them being declared in the header. So here we're saying a student class is going to have 1, 2, 3, 4, 5 variables, 5 attributes. String, string, student number, string, which is an email, and double current average. Okay, so there we go. These are our attributes, but they're set to private, meaning I can't access them somewhere else. If you look here, I've created a student object, and I'm just going to get rid of this one because I like, this is the way we're going to mostly do it in this class, for better or worse, like it or not. If I wanted to like tell, actually first, how about this? I'm going to make this just say public. I'm going to make everything public inside this object for the class. And when I do this, I can say like, well, what am I dot, and it'll actually tell me, and actually technically I should be doing this. Like, look, I mean, the IDE is telling me what I can access. Currently, there's only attributes in there. So that's why we see current, average, email, first name, last name, student number. The only methods in there are the constructor and deconstructor, but we don't call those directly, like explicitly like we do other things. But we will add the getters and setters, and you'll see them pop up in this dropdown. This is what happens when it's public. I can say, oh, I heard a boop. Are you sharing your screen right now? You can't see it. I am sharing my screen. What does that mean? Okay, so Lucas, you can't share my screen. Okay, it looks like he's trying to rejoin. What does the arrow mean? So in other languages, you'll do like the dot, current average, but that actually only works if the thing you have is, okay, let me go back. You raise a very good question that I should have brought up earlier. So if I have a student, remember a student is a student object. I would do like a student dot current average. And this would give me the current average of the student. Okay, that's what it is. But the problem is, what am I is not a student. What am I technically is a pointer. So I should be dereferencing this pointer before I can do dot current average. There. And it's happy. So really I should be saying, okay, go to the pointer, go to the actual thing there, and then access this attribute from it. Computer scientists are notoriously lazy. That's why we write code to solve all our problems for us, because we're too lazy to solve our problems on our own. So I don't want to write this. Look at this. These are 3 extra characters, a parenthesis, an asterisk, and then another parenthesis. My goodness, think of all the time I'll save if I come up with a shorthand to mean do all that. And the shorthand is replace the dot with the little arrow thing. So it's a way of saying, from a specific instance, tell me the current average. Remember, I could do this as well. And now I've created, when I hit run, I'll have 2 different instances of a student object. Now, both of them, when they're created with the way the code's written so far, their current average is going to be set to 100 by default. So they both are John Doe, J Doe at St. FX, current average 100, student number all zeros. They both have those values, but that's just because those are the default values. They can have different values in there. It's just like the students in the class. All of you have a first name, but you'll have like different first names. All of you have a student number, but you'll have different student numbers. So these are 2 instances of, well, these are actually 2 pointers to 2 different instances of student objects. And depending on what we set those attributes to, if I do this, these might be different values. So I'm saying which specific instance I care about and then get the information from that instance. We'll see plenty more of examples of this as we go forward. But hopefully that answered your question. It's basically the same as the dot, but we're lazy, so we have this beautiful shorthand to mean like dereference the pointer. So hopefully that helps. All right. So yeah, going back to here, we see that when I was doing what am I dot current average, it's happy with this because I'm in a different file here, hello world.cpp, and this attribute is set to public, meaning anything like in here, all the files in this project can see what the attributes are inside that and access them and change them. But we don't want this. We want to set some restrictions on what we're going to allow the people using our code, even yourself. I know I realize you're writing your own code to use your own code, but even the people, even for yourself, we want to set some restrictions on how we can access, like which information we can access and which information we can change and maybe some rules about how we can change those things. So if I go back here, I've got this. Suddenly, it's angry at me. And what does it say? Member, student, blah, 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 is inaccessible. That's basically saying this was set to private. You're not supposed to have access to this. So that's a restriction that setting something to private does. And again, you might be thinking, but that's stupid. Just make it public so you can access anything. And you know what? When I started learning computer science, that's what I did. Because I'm super lazy. So I set everything to public. Don't be like me. You're not going to be allowed to be like me. You'll lose marks. You're going to want to use private and public properly. And that comes with experience. And we'll see more examples of this. Now, which of these attributes should have getters and setters for? Right? Which of these should be able to access and modify? Should there be any rules about how we modify them? So, adding to header, let's add a function to the header that's going to be like a getter. We're going to add getters and setters, but all these functions we're going to make public because we want these functions, getters and setters, to be public, because when they're public, we can use those things. We can make methods private as well. That means the method can only be used within the same class. Again, more on this later. This is a case of a lot of new information that won't really come together and make sense until a little bit from now. But we want the methods that we're going to be able to use elsewhere in the code, like in the main, to be public. Anything private we can't access. So we're going to add all of these things. I'm going to add, it looks like a getter for first name and a setter for first name. Okay. A getter for last name, a setter for last name. It looks like I've only got a getter for student number. And you might say, well, why not have a setter? Well, you know what? Once a student number is set for a student, it's not going to change. It should not be changeable, right? And then maybe we've got a get email. And then we've got a get current average and a set current average. And maybe, you know what? Maybe on our set current average, the average needs to be between 0 and 100, right? So maybe I should set a rule on the setter that if someone actually tries to set a current average to 1,000, it shouldn't work. So we'll get a sense of how, with the getters and setters, we have a little bit more control over how we interact with these attributes. So get sets it initially, and get has the ability to change a set. Wait. No, get only accesses the information. Set makes it so we can change the information. The default values that we can see are those that are just set here. Because when we create an instance, it's going to call the constructor. And within the constructor, we've got this code. But we can change those values later with the getters and setters. And we'll do that. We'll do that. So I'm just going to go back. Where was I? And I'm going to copy this because I'm really lazy. And there. I'm going to add all these functions here. Get first name, set first name, and so on. And then look, it's already saying, this is a perfect example of the IDE, Visual Studio, being a little overzealous in its recommendations here. It's telling me oh my gosh, you just declared something, but the function's not written. Well, yeah, I know. I literally just declared it. Now I'm going to go write it. Anyways. So here's the getters and setters for first name. I'm just going to copy them in. We're going to go here. We're going to go down here. And boom, there we go. We're going to say, okay, what's its return type? It's a string. From the student class, I know we're in the student class, but we put this here. I'm defining get first name. This is get first name here. Look, because I added them, it's not angry anymore. If I misspelt this though, if I said get first names, well, it's going to be mad because it's going to say, there's no such thing as get first names. And that's because it's get first name. So we got to be careful here. It's really picky, like everything. But this function, all it's going to do is if I call it, it'll say, okay, what's that person's first name? But then I can also tell the computer, well, here's another one. Its return type is nothing, void. And then from the student object class, we're going to set the first name to a given string. So let's do this now. I'm going to go back to, let's save this. I'm going to go back here and I'm going to make this like student A. Nope. And do it again. And student B. Okay. So here's what I'm going to do. First, I'm going to do cout student A. No, student A. Get first name. It's a function. Okay. And I'm going to do the same thing with, well, that's supposed to be get, not set. There, with B. So this should immediately tell us what the students' names are off the bat, like right from the get-go. So I'm going to build it, and I'm going to run it, and we should expect to see the name John printed out twice because by default, whenever we create it, the first name is set to John. So let's hit run. Let's go back. No, wait. There. And what do we have? John. Good. But now let's have some fun by changing this. So next I'm going to change student A. Someone type a name in the chat. And we're going to set their name to that. And then someone type another name in the chat. And then we'll set student B's name to that. So, I don't know, someone, you got to give me a name here. Come on. All right, Rasputin and Bob. I'm going to go with Rasputin and Bob. I'm definitely going with Rasputin. Okay. And Bob. And I'm going to now call the exact same code. There. I'm going to call the exact same code, but I mean, I'm calling this code after I changed those values. So when I hit run, I should see John and John, but then I say student name, or pardon me, student A, your first name is Rasputin now. So it's going to, okay, yeah. And student B, your first name is now Bob. So then down here, when I say, okay, student A, what's your first name? It's going to be Rasputin. And then if it's student B, like on this line, it should say Bob. So let's rebuild, hit run, and see what happens. Make sure I'm not going crazy. Come on, taking ages to build. Okay, let's hit run. Hello? Okay, sometimes I find on my computer I need to like hit like a button on the keyboard in order for it to work. So anyways, we see John, that corresponds to line 14 and 15. Then on 17, 18, we change their names to Rasputin and Bob respectively. And then on line 20 and 21, I print out student A's name, which is now Rasputin, and then student B's name, which is now Bob. So there, we just use the getters to access information, and we use the setters to modify the information that belongs to a specific instance. Remember, student A and student B, they're both pointers to students, but they are two separate, completely independent student objects that they're pointed to. Would you be able to upload the CPP on Moodle? I think it's pretty useful. This is going a bit fast. Okay, I'm going to slow it down. I have just been bombarding you with information. I might upload this on Moodle, but I might take the lazy approach and just say, go to whatever point in the lecture being recorded this is. But I'll if you send me an email, I'll upload it. If you don't send me an email, I'll forget and it won't get uploaded. Okay, so it's going a bit fast. So at this stage, all I have done is, I mean, we can ignore this. I said, okay, created a variable called our student A, and it's a pointer to a student, and then student B, which is a pointer to a different student. And then I'm saying, okay, make a student, make a student. When I call this right here, this goes and runs the constructor, this right here, this very special method. And all this code gets run. And to prove that for you, I'm gonna do this. Okay, so here's a test for you. I'm gonna build this. How many times should I see the string I ran printed out when I hit run. Oh, do I not have, let's rebuild. So how many times should this be run? You don't have to type in the chat, just think to your head. Like, how many times should I see I ran? Well, we see it twice. Why? Well, on line 9, I created a new student object which goes and runs this constructor once. And then we see this. All the code in this constructor here, in this method, will run, no matter what I put in there. Like in the assignment, you're going to want to do some file I/O in your constructors. But then back here, well, on the next line, line 10, I call this again, which means, oh, okay, go call the constructor again. So it calls this function again. And we see I ran. I'm going to get rid of that, though. Then here, all I said is, okay, student A, what's your first name? And because this function ran here, this method, this constructor, this line exists, which says, okay, the variable first name, which if we go back to our header, we know is a private string. First name, like, tell me what it is. And, well, it's John because that's what this line of code said. Whenever we call this constructor, the attribute first name is always going to be John after it runs. Last name is always going to be Doe after it runs, and so on. So I say, okay, what's your first name? What's your first name? I ask these two student objects. I know these are pointer to student objects, but I'm lazy. We're going to ask the two student objects that are pointed to by these pointers what their first names are. And it's going to say John and John. Let's hear it. Why do you put underscores in front of them? That's just a convention. The convention is all of your things that you want to be like private, that are like attributes for your class. We just put an underscore in front of them. And it's a convention that we like to follow in C++ because anyone that looks at this goes, oh, that's an attribute for a class. That's why. It's not really, it doesn't mean anything other than just a convention that people have applied meaning to. Yes, so, yeah, we go here. I now say, okay, student A, I know your name was John. I know when we ran the constructor, your name was John, and it's still John. But now, forget that it's John. Override it with the name Rasputin, with the string Rasputin. And student B, the thing you're pointing to, look, I know your name was John, but get rid of that. Your first name is now Bob. So these two instances, remember that. Like, okay, these variables are now set. These attributes are now set. And then when I access them again, well, we get the updated versions. I could do this again and say, student A, you're now Sally. And I think Ricardo was another one suggested. So we should see John, John. Then we changed them to Rasputin and Bob. And so then she printed out Rasputin and Bob. And then we set them to Sally and Ricardo. And then we hit run. Then we should see Sally and Ricardo. Nope. Now let me hit run. I closed it too quickly. John, John, Rasputin, Bob, Sally, Ricardo. I heard another boop. Okay, so when you're calling them, you don't need to put the underscore. Well, no, hold on. I never called these from here. I never called them. This is the function get first name. I didn't say, I never said that. I said get first name, which is, if we look at the header, a function here. There's no underscore in front of it. If I put an underscore in front of it, we would want the underscore here. But I called the function get first name. And then inside here, when I used get first name, I returned the attribute first name, which you'll see does have the underscore. You're thinking too hard. You're trying to connect dots that don't exist. Yeah, okay. Yeah, you're thinking too hard. Classic computer science mistake. Remember, we're lazy. Be lazy. All right, so these are our getters and setters for first name. Last name will be the same thing. So I'm just gonna copy this. Same idea, same idea. Now, student number. Since it doesn't make sense to change a student number, we're only going to write an accessor method. This is not, like, we could write a setter for it. We could write a setter if we really wanted. We can write a setter for the student number so we could change it. But you know what? In my implementation, with the code I'm building, it's not really going to make a lot of sense to modify this value ever. Once it's created, it should be set. Now you might be saying, well, hold on, by default it was set to all zeros. How are we going to change it? We'll see some overloaded constructors in a moment. But for now, I'm just going to write the accessor for student number, but no setter, because I don't want to change this value. It should be, once it's created, it should stay the same. And then leave email alone too. Great, we'll only access it. Your email's not going to change. Your SaneFX email stays the same forever. So there you go. Now, I could say this for my getter. Okay? And this makes perfect sense. Get me the current average. Great. But when it comes to the setter, I could make it as simple as the other ones, where it's just like, it's basically the same as this, except we're updating the current average and it's an integer. I could do this, but because I want to control the information a little bit more, I'm going to put this condition. I'm going to say, okay, setter, here's your deal. You're going to return nothing, but the function set current average, you're going to take your double new average, but you're only going to work if the new average is less than or equal to 100 and greater or equal to 0. You're not allowed to have more than 100 or less than 0. Okay? So if it doesn't work, it's not going to do anything. But if the average is in the right range, it's going to work just fine. So here's a really great example of writing a setter in such a way that it kind of guarantees that the data within our instances of our objects is consistent. It's set the way it's supposed to be. So this is perhaps good motivation for why we want that middleman. That middleman kind of is going to ensure correctness, that we're using this class the way it's intended to be used. Like if I'm writing this code, I'm writing it for a purpose, and I'm going to want it to act a certain way. And with stuff like this, it gives me a system for enforcing that it's used the way I'm intending it to be used. Since the new average is a double, should the bounds be doubles as well, not ints? I think it'll work just fine, but we could do that. In fact, you could just do the dot and it'll work too, but yeah, that'll work. And actually over here, oh, it is set to a double. I just wanted to make sure. So yeah, there we go. So we've got our getters and setters. So now, if I go back here, I'm going to get rid of all this now. Leave Rasputin and Bob though, because I like it. If I say a student, like we've got, oh, I guess it's student A actually. Look, like we've got all the new methods we wrote. We've got get current average, get email, get first name, get last name, get student number, set current average, set first name, set last name, and the deconstructor. The attributes are gone. Like we don't see the attributes anymore because they're private. We're not supposed to access them, but the methods are public. I could put a method, like if I moved this, if I put get first name here, suddenly this is going to be mad because, oh, did it not update yet? The IDE probably needs to update. So I set get first name to private. I go here, let's rebuild. Why am I doing that twice? Ah, now it's angry. What's it saying? Member function already declared or defined. What? Did I cut it and not get first name? Oh, I meant to cut, not copy. Okay, let's try this again. Ah, now look, it's angry. Look, yeah, I'm not supposed to access it. It's set to private. You're trying to access a private method. That's no good. So let's put it back where it belongs. There. Now it's happy again. Okay. Hey, look at that. I used bobbed. Okay. And this was just doing a simple example of calling it. Ah, and here I am explaining what I explained a moment ago about how if I'm doing it with the what am I example that I had back here, where was it? Here. how it's a student pointer. Here's an example. Like technically, I should take the pointer, dereference it, and then access the function, but this is the shorthand, like we talked about. And of course, here, look how good I am. I'm deleting what am I. This is wonderful. Yeah. Recap so far. So we defined a student object. Header, where we say what we're going to do. The class, where the actual code we're writing goes. And then we created an instance, actually in the code that I was doing, like we were doing here together, we created 2 instances of student objects that were pointed to by student pointers, and then we interacted with them just because. And we didn't really do anything overly useful, but we just, poked and played around with this code that we wrote. So here's an example of creating 2 instances in static memory. How many student objects do I have? Well, 2. What is the instance A student's first name? Well, it should be, what was it? John by default. What is the instance first name? It should also be John. Another constructor. Okay. So we created 2 instances of the same object that had all the same values, right? The default values, which were John Doe, zeros, J Doe at sandvix.ca, and 100. Okay. But that's not going to be great all the time because, well, what if you want to make an instance and just set the values accordingly on creation, like set the values to what we want them to be when the object is created, instead of creating one with default values and then going and changing them with getters and setters. I mean, we even saw that we don't have a setter for email address and student number, so how on earth are we going to change those things? So it's not ideal, so we're going to make a new one. So I'm going to add to my header a definition for a new student constructor. It's basically, I copied student, open parenthesis, close parenthesis. I copied that, pasted it, and then added basically the variables, the parameters I want to be able to set for the attributes within an instance of this class. So again, I'm super lazy, so I'm just going to copy this code. I'm going to go to my header and say there. So now, what's it saying? So it's already telling me, okay, so you want a constructor that takes 1, 2, 3, 4, 5 parameters of different types, but it's got the same name as this function here, this constructor, but that's okay, because you might remember we could do function overloading in C++, where you can have multiple functions with the exact same name, as long as their parameter lists are different. Now, we would need to go and declare this now, or like actually write the code for this. So if we go back to our student C++, here, let's do this. Oh, and I guess I'm missing student. There. So now I'm ready to write the code. I'm going to zoom out just a titch so we can see it a little better. Hopefully that's still readable on the stream. Let me know if it's not. There. All I'm going to do is I'm just going to copy this, but instead of setting them to these default values, I'm just going to say, okay, here, fname, oh, nope. Fname is a string. This should be lname. Student number is snum. Email is just going to be email. And current average is going to be there. Nope. There. That's it. It's the same thing. Now, if I go back here, I'll leave student, I'm going to get rid of these for a moment. So I'm going to create student A. It'll have default values, but here I'm going to use the second constructor, that not default constructor. I'm going to call him Rasputin. Oh, but of course that has to be a string. Smith. And then what do I need next? Oh, it's telling me here. Their student number is 1, 2, 3, 4, 5, 6, 7, 8, 9. Their email is rsmith at, again, how did I forget my quotes? And their average is 51. Rasputin's got to get their shit together. Now, if I go here and say, we'll get the first name, student A, like for student A, it's pointing to a default student, like a student that was created with the default values. John is going to be the first name. But student B goes and runs not the default constructor, but this constructor, because it goes and finds the one with the matching set of parameters. String, string, int, string, double. Well, there, double. So it'll go and find the one that matches, and it's going to go, okay, student. Well, this one takes nothing, so obviously it doesn't match here, and it's going to go, okay, string, string, int, string, double. Ah, this is the one I'm going to call. So it's going to set them to whatever the values passed as parameters are. So when I hit run, we should now see John and Rasputin. And hopefully I did not make a liar out of myself, and let's have a look. John, Rasputin, fantastic. Yeah, and then here I am writing it like I just did. Here's an example of me making two in static memory, Bob, Smith, whatever, B Smith, and then here's Sally as well. And creates two instances, each with the set values, print out each first name. And here's an example of doing it with the pointers. Again, this is the way I like to do it. I've made Bob Smith and Sally McLeod, so we should see Bob Smith, Sally McLeod. And of course, I'm being good and deleting these instances after. You know what? I'm so bad. I need to delete. Now remember also, when I delete these things, it doesn't delete the variable student A. It deletes what the thing student A points at. So it's deleting like the right-hand side here, not the left-hand side. Okay, more functionality. So far we have accessors. This is pretty useless. Why is the pointer method preferred? It's not that it's preferred. In fact, people will get really angry with me. If I was teaching a C++ class, this is not the preferred method. It's just, there are different ways of doing it. But because I'm not really teaching a C++ class, I'm teaching a data structures class, and part of it is like object-oriented programming. Because almost all other object-oriented programming languages are using pointers only. You don't have a choice to have like a variable containing the instance of the object. It's always a pointer to an instance of an object. Because all the other languages work that way, I'm going to specifically make us do it that way, because then it just enforces what's typical everywhere else. I know a lot of people feel like when they're seeing the pointers, they're like, whoa, this is so different. Why are we doing it the different way? Actually, no, this is the way you've always been doing it. If you were a Java programmer, a C# programmer, a Python programmer, it's all pointers to something. A lot of people miss that fact because we don't have to deal with dereferencing because the language does it for us automatically because it knows it's going to be a pointer. So, I mean, it doesn't matter, right? We don't need to get explicit with our dereferencing because the computer doesn't need that instruction because there's no ambiguity of what it is to do. So, long-winded answer is, it's not that it's preferred in C++. It's that it is the way like all the object-oriented programming languages work. So we're going to do it that way so it's consistent with your Java, C#, Python, and whatnot. And all other languages you'll like. So yeah, we've got a very boring class so far. Let's add more functionality. Two popular methods to include in classes are a toString and equals. Now, in some programming languages, this is done much better. Okay? Your toString and your equals are kind of like standard methods you want all of your classes to have. ToString will be like a function that basically stringifies what your object is. Now, what a string representation of an instance of an object should look like is entirely up to the programmer. For students, maybe it'll be like their first and last name or something, right? And then equals is to check if two students are equivalent. Now, there's a difference between having two pointers pointing to the same student object and two pointers pointing to different student objects, but the student objects happen to be equivalent. For example, maybe their student numbers are identical. More on this in a moment. Other programming languages do these like standard typical methods much better than C++. In C++, it's really hacky, it's really roundabout, so I'm going to warn you a little bit, and we're going to cheat a little bit to make it work a little nicer for us, because again, C++ is old, and the other languages had the luxury of learning from what worked and did not work with C++, but C++ was in too deep to make significant changes. The way I like to talk about C++ is people took a programming language and then started stapling more ideas onto it willy-nilly, and here we are. Okay, toString. This is a special function that returns a string version of object. This is awesome for debugging purposes because you're gonna have pointers to objects and you're gonna forget which one you're pointing to. What's its version? I don't know. Oh, this is the one that's labeled Bob. Whatever that would be. Okay, add this to the header. Okay, and add this to the class. Here we go. So if we add this to the header, it's gonna say, all right, well, we are defining a function, a method that's gonna return a string called toString. And we're gonna add this to the class. So it returns a string from the student, toString. And what are we gonna do? The string s starts with first name plus last name. And then we say s equals s plus. So just append to that, open parenthesis, student number, close parenthesis, space. And then append to that email, and then have a tab, toString current average, which is interesting because we're seeing toString here. But here's the problem. This toString right here is not the same thing as this toString. This toString is from the standard library, and current average is a double. So this toString takes a double, and it's going to convert that double into a string so it can be appended to our string. Also, huge, this is such a common mistake people make. So I'm gonna make it very clear. Listen, your toString does not print anything out. It is to return the string, not print it out. Remember this. Chances are a third of you are gonna make that mistake. That's okay. But hopefully you'll remember, oh, I made this mistake. Oh, that's right, because I didn't return, I printed it. This toString, though, will be called on an instance of a student object. I'll show you an example. So I'm gonna take this, add it to my header. It's going to be public, so I'm gonna go down here, there, and I'm just gonna copy all this, copy, student C++, and there we go. There. So when I call this, I'm gonna go back here, and I'm gonna say, equals toString. And then I'm going to do the same thing with student B. And I hear a question. What? Very lost right now on the function in the class. I'm not sure what you mean. So the function here.
Like the actual, like in the class file.
Yeah.
Just like what's going on there. I'm seeing like 22 strings and like a lot of standards and definitions. And I'm just.
You mean this code right here, eh?
That's the logic of it.
Okay, but it's this code in specifically that you want me to unpack a bit?
Yeah.
Okay, so all we're doing, and you know what, we can unpack this a little more. I'm going to declare a variable, and it's going to be a variable that's created only for the purpose of existing inside this function. This variable s will be deleted once this function is done running, but of course it'll return the value as well. So we're declaring a variable called s. It's a string. This is going to be the string that we're going to return. This is where we're going to store that information. So then I'm going to say, okay, s, you're going to be equal to first name concatenated with the space, concatenated with last name. So whatever this instance's first name is, take it, add a string that is a space, and then add the last name. So after this stage, we shall see, and you know what, let's do this. Print out s. There. So we'll see, when I call this function, I want to see how it changes every time we add something to s. So we've got s. S is going to be first name plus space plus last name. So the first time it'll be like, this would be the defaults after this line. And then down here, I'm saying, okay, now take that same string and append to it. So this is just saying like s equals s plus. So take the string s, append to it this information, and then store that in s. And what are we appending to it? Well, space, open bracket, open parenthesis, plus whatever the string version of the student number is. Because in C++, we can't concatenate a string and an integer. Because C++ is going to be like, what the hell does a string plus an integer mean? I know what a string plus a string means. That means concatenate. I know what an integer plus an integer means. That means addition. Well, what the hell do you mean when you add the two together? So this right here is the way that we tell C++, look, I know you're an integer, just become a string. So this will convert that integer into the string version of that integer. I think in this case, we might have a problem with the default one because it'll be all zeros, which might just return 0, but we'll see. And then append another string that is the close parentheses, and then we'll print it out. We wouldn't want these in here realistically, but I'm just doing this for demonstration purposes. And then down here, we're doing it again. We're doing this again. Basically, take s, append to it the email, and then this is a fancy way to make a tab. So we'll get like 4 spaces, plus the string version of whatever the current average is, and then we're going to return s. And then here, I'm going to store whatever this function returns, this method returns, in the string version A, and then similarly for student B, the string version B, and then down here, I mean, I can do whatever I want with these string variables now, but all I'm going to do is just print them out. All right, let's build this code and see what happens. Now, when we call this, here's what I'm expecting to see when I hit run. We create student, and I believe I removed that print from the constructor. Yeah, so there's no print here anymore. So what are we going to see? We're going to see, okay, this is created, and then we should see printed out student A's first name, which is John, and then student B's first name is Rasputin because we set it there. Then I'm going to call the function toString on student A and also student B. Remember, these are getting us to 2 different student objects. And I'm going to say, okay, student A, what's your string? So when we go, we call, and we're going to run this code right here. So we should see John Doe printed out, followed by John Doe, open parenthesis, student number, close parenthesis, and then last line should be John Doe, open parenthesis, student number, close parenthesis, email, tab, current average. And we're going to see that for also Rasputin, and we're also then going to see it printed out again because I just immediately after calling these functions print out the string that was returned by that function. So let's see what happens. See if I was right. I hope I'm right. I should be right. Oh no, not with errors. Oh, well, because it got angry because I probably closed the console the wrong way last time. Okay. Perfect. John Rasputin, John Doe with our student number, which it formats 0 as just zeros despite all being zeros. Actually, maybe this is a good argument for making student number actually be a string, not an actual number, but whatever. Then the next line, John Doe, student number, email, tab, 100%. And then we do the same thing with Rasputin Smith, their student number, Rasputin Smith, their student number, email, tab, average. And then at the end of it all, here, we call these 2 lines here, and that's what these 2 lines are here. Did that help you? Let me know if that answered your question or not.
For the toString, so the toString within the actual like function is standard toString.
Yes, from the standard library, call the toString function, and here's a double. You'll notice that when I call this toString, we don't put anything in there. This is a toString being called, like this is a method that this class has. Now, you might remember a moment ago I was saying, you know, C++ doesn't do this a nice way. And this right here, what you have identified. The fact that you're like, well, hold on, why are you using a toString from the standard library? Now you're writing your own toString, but it's not in the standard library. You're applying it to the student object. This right here is a perfect example of where C++ does this poorly. What oops, I think I deleted the wrong things here. What C++, other languages, what they'll do is they've standardized their toString such that you would call toString on a double. You would call to, like here we've called it on a student object, a pointer to a student, then we dereference. But here we're calling it like this, like the a student dot something. But and if this was a double, you'd tell the student to like, hey, tell me your toString of it. And there's even better improvements too that I won't get into that other languages do. But here's a classic example of like, well, now we have conflicting things. Like, why is this toString from standard library and this one we're writing it? Well, that's because C++ is old and the other languages learn from it, and you know, it's in too deep to make any significant changes now. I heard another boop. Why couldn't we just call it something else in our header? We could, but so like in Java, it would be toString. And this is like what everyone would call it. You're right, we could do that to eliminate ambiguity, but we'll just call it toString because that is typically what we would call this thing in programming languages like this. In Python, it's called repr though, so repr is completely different. But anyways, yeah. And there's other neat things you can do with it, but anyways, that's that. I guess we'll have to end here because we're out of time, but hopefully that helps quite a bit.